Hello everybody, welcome to this video. Today we're going to start with just reviewing what do we already know about functions, and then we're going to move on into a little bit more of domain and range. So let's review some of these things about functions. We're just going to say, is this a function or is it not a function? You don't need to write all of these in your notebook, but I'll tell you which ones you do need to draw or write. If we look at the x's here, if this is a function, then none of these should repeat. 1/2, 1/4, 1/5, 1/8, 1/10. Those are all different, and they all get a y. So since none of these x's repeat with different answers for y, this is a function. Next one, we have 14, 15, 16, 17, 18. All of those x's are unique, all have a y as an output, so this is a function. Negative 0.2, 0.6, negative 1.3, 1.0, negative 0.2. These two are the same, and they have different outputs, so this is not a function. Negative 24, 21, 24, negative 27, 29. These are all unique, different x's. They all have y's, so it's a function. Please draw this one in your notebook. We see that it is a curve that's going sideways, and this curve wants us to find f of 4. So to find f of 4, this is going to be the x. We're going to look for the x of 4, and when x is 4, y is 2. So that has the coordinate 4, 2. Besides just finding the output of this one, which was the y of 2, we can decide, is this a function or is this not a function? This curve is going like this. If you look at any x besides this one, this is the only one that's good. All of the other x's, if I look at negative 2 and follow it up, I'm going to get a point on the graph. But if I follow it down, I'm going to get another point on the graph. So for negative 2 for x, you get two different answers. Up here's an answer, and down here is an answer. Since negative 2 has two different answers for y, it is not a function. So even though this is using function notation, it's not a function. Go ahead and draw this graph in your journal. We need to make the y-axis go up past 5. 0, 5 is a point on the graph. F of x equals 1. We're trying to find x. If we know this part is the answer. 1 is the answer you get whenever you plug in something for x. When in this line, when on this line is 1 the answer? 1 is the answer whenever 6 is the x. 6 would go inside the parentheses to get 1 as the output. We should know how to do this already. You just replace x with 3, so you'll put 2 times 3 plus 6. You should be good with a negative number, but we can write it anyway. Let's do this one. H of x equals 6x plus 4, and we're going to plug in the number negative 8. That means this negative 8 is replacing x. 6 times negative 8 plus 4 is equal to negative 48 plus 4. Look at these, they have different signs. One of them is negative, one of them is positive. That means they're going to, one of them's pointing up, and then we have negative 48 pointing way down there. These are going to cancel each other out, but just a little bit, to get negative 44 is h of negative 8. One more time. We'll only do one of these in this video. if you're given a list of ordered pairs and it asks you for the domain and the range, then the domain is the set of the x's. But we need to put the x's in order from least to greatest. -6, 2, 3, 8. All I did was I just looked at the first number of each ordered pair, and that's the domain. Then the range. We're going to do -9, 4, 7, 8. There's our range. Is this a function? Well, none of the x is repeated, so yes, this is a function. Here's one that somebody missed yesterday. This first number, -1, it has a line going to 4 and a line going to 3. +1 also has a line going to 2 different numbers. That means -1 as the x is paired with 3, and -1 is paired with 4. -1 for the x has 2 different y's, so this is not a function. It does have a domain and a range, but because the x repeated, it's not going to be a function.